This is CS1101, lecture 10.1. Today we're going to work through programming examples using arrays and end with a discussion of search. And in this case, we're going to be searching for some entry in a larger body of data. So, as our first two programming examples that we're going to work through, we're going to write a method called swap, which will accept an array and two integers. The array will be the array of integers that we want to perform the swap in, and the two integers will be the indexes which we wish to swap. So given the array A1, which has elements 12, 34, and 56, then when we pass it A1, when we pass the method swap A1 as the array and 1 followed by 2 as the integer parameters, and we print that array out after swapping, we see that the element 1 and element 2 have been swapped. So where it was 12, 34, 56, it is now 12, 56, 34. So we have swapped element 1 and element 2 in A1. And then in our second programming example, we are going to write a method called swapAll, which accepts two arrays of integers and swaps the entire contents. Now we're going to make some assumptions here. We're going to assume that the two arrays are the same length, otherwise swapping the two arrays becomes a bit more difficult. Other than that, it's assumed that the arrays contain integers as it says. And so we would pass it A1 and A2 with these contents. And after passing A1 and A2 as parameters to swapAll, A1 now contains what used to be the contents of A2, and A2 contains what used to be the contents of A1. So let's work through these two programming examples. Example that we want to work through, we need a method called swap, which is going to accept an array and two integers as parameters and return nothing, because it's going to do the effects, or it's going to have the effect on the object which is passed. So the integer array object called A, we'll go with ARR, and then our two parameters int I and int j. So this just comes directly from the directions of the example. So we want to swap element I in R with element j in ARR. To do this, we need to have some sort of temporary storage location to store the location, or store the value which is in element I. We know we're dealing with integers because this is an integer array, so we are going to create an integer called temp, and we are going to assign it the value in ARR element I. Then we will assign element I the value in element j. So the value which was previously stored in element I gets stored in temp. The value which was previously stored in element j is stored in element I, and now we need to move what we stored temporarily in temp into element j. So ARR element j is assigned the value stored in our variable temp. We don't return anything because, remember, we're passing in the reference to this array that we're calling ARR, and then we're directly affecting the object located at that address. So the effects of this method are going to be seen at the location passed to ARR. So any use of this method where we pass in some object is going to see directly the effects of this method on that object. So let's exemplify this. Let's show what we're talking about. So let's create an array. So int, and we'll say array1, and we will give it the values 1, 2, 3, 4, and that's good. So we can easily tell the order of the array. And we're going to do system.out.println, and we're going to do arr1 dot get rid of that dot toString. So we're going to print this array as a string. Remember, you can't print an array directly because what's actually stored in this variable is the location of array arr1 in memory. So we can do that just for fun. This is the location of array arr1 arr1. So hopefully this makes sense to you at this point from based on the previous lectures. So if we print out arr1 directly to the console, that's the location. To print out the contents of array arr1, we need to do array r1.toString. Now let's call our swap, and we'll pass it our array. And what we're going to do is we're going to swap elements 0 and 1. So that should make our array 2, 1, 3, 4 instead of 1, 2, 3, 4. And then we will again print out the contents. So let's run this code. So notice the play button right here beside the main method. We can just click play right there and run array_fun.main. This is the location of array. This is the contents of array1. So notice what I did wrong here. And this is something that is easy to do wrong. I used array1.toString instead of importing javautil.star and using the library called arrays. So let's make sure that that's in there. We can always just check. So to make sure you're importing the right thing, yep, arrays, it's right there. Arrays. So we will do arrays dot toString, and then we'll give it the array, which is arr1. So notice what we did wrong previously. We used arr1.toString. The toString method built into the array object actually converts the value of the memory location to a string. So this arr1.toString, open and close parentheses, converts the address stored in this variable. So the address of our array object, it converts that directly to a string. So this is the address of our arr1 object. This is the address of our arr1 object converted to a string and then converted to a string again. So if we want to see the values printed, we need to use arrays.toString, not arr1.toString. Very different. So let's also change this down here. Arrays.toString. Notice it's already popped up here, so we'll just push tab and then we'll give it the parameter arr1. Now let's run this again. Oh, that's more what we wanted. So here's our address of where our array is located in memory. Here is the contents of our array, 1, 2, 3, 4. And here is the contents after swapping element 0 and element 1. In swap all, we want to be able to pass in two arrays as parameters and then put the contents of the first array into the second and the contents of the second into the first. So we want to swap contents of ARR1 into ARR2 and contents of ARR2 into ARR1. So let's create the method public static void because we're not going to be returning anything. We're just going to be affecting the objects that are passed into the method just as we did with our swap method. We'll call it swap all. We're going to give it two parameters, an integer array called ARR1 and another integer array called ARR2. To do this, we can't manipulate the addresses. We can't just say something like AR. It would be tempting, perhaps, to try to do int array temp equals AR1, AR1 equals AR2, AR2 equals AR1. This might come into your mind to try, but it won't work because all we're doing is taking the address stored in ARR1, storing this into a new variable called temp, taking the address stored in ARR2, storing it in ARR1, and then taking the address ARR1 and storing it into ARR2. So we're just shuffling addresses around. When we come back out here, or sorry, not into swap, but when we come back out to the caller, which in this situation is going to be the main, there will have been no effect to the arrays passed into this position and this position because nothing in here actually changed the objects. We just moved the addresses around inside this method without actually changing the object that exists in memory. So we need to actually change the individual elements, thereby changing the actual object. So let's use a for loop so that we can process each element of these arrays. And we said we're going to assume that these two arrays are the same length. So let's say for int I as our counter equals 0 because we want to start at the first element of the array, and arrays start from index 0. And we will go until I is no longer less than AR1 dot length. Notice it's not length open and close parentheses because this is not a method, this is a keyword. Or a field. Keywords and fields are sort of two names for the same thing in this situation. So ARR1.length is a field which contains data about ARR1. In this case, is how many elements exist in that array. And we are going to update by simply incrementing I. Now what are we going to do inside this loop? We are going to take the ith element from ARR1 and store it in ARR2, and we're going to take the ith element from ARR2 and store it in ARR1. To do this, we will need our temporary variable, so we'll call it int, or we'll make it a type int, call it temp, and we will assign it the value AR1 element I. Then we are going to take AR2 element I and store it in AR1 element I. So assign AR1 element I the value AR2 element I. So that moves element I from AR2 into element I in AR1. Now to move this value that we stored from AR1 into AR2. Element I equals temp. So notice what we're doing. We store the element I from AR1 into temp, store element I from AR2 into AR1 element I, and then finally move the value we temporarily stored in temp into AR2. So this should go through and process each element of this array and perform the swap that we want to see. And we can check to see by creating a new array called AR2 . We will give it 5, 6, 7, 8. And we are going to print, this is the contents of AR1, and system.out.print line. So we'll print out AR2 after converting it to a string using the arrays library, the toString method from the arrays library. So this will print out our initial location of AR1, then the contents of AR1, then the swapped contents of AR1, and then we'll do a swap all with AR1 and AR2. So we have our address, which is this first print line. We have the initial contents of AR1 as a string. We have the swapped contents of AR1. Then we have the contents of AR1 printed again just for reference. And then we have the contents of AR2. Now let's swap them. Swap all, AR1, AR2. And we'll print the resulting values again. So now AR1 contains 5, 6, 7, 8, and AR2 contains 2, 1, 3, 4. So our swap all swapped the contents of what was in ARR1, 2, 1, 3, 4 into array 2, and it swapped the contents of ARR2, which was 5, 6, 7, 8, into array 1. For the next pair of examples, we're going to write a method called contains, which is going to accept an array of integers as well as a target integer as parameters. And if the array contains the value which is stored in the target parameter, we will return true. And if that value is not one of the elements in the array, then we will return false. The second method we will code is called round all. We'll pass in an array of doubles as a parameter, and we will round each element of the array to the nearest whole number. So there's going to be one parameter that's an array of doubles, and we will modify that array, replacing each element by a rounded version of the element to the nearest whole number. So round all, we won't have to return anything. It'll be a void method because we're going to be affecting the actual object passed in. Contains will have to return a Boolean value. So let's code these. So our next example is called contains. We're going to write a method to return a Boolean value, true or false, for if an array of integers contains the target value. So it'll be a public, static, and then not void, because we're going to be returning a Boolean value, and we're going to call it contains integer array called array, and our integer called target. Let's give it a comment. Returns true if target value exists as an element of array. So what we need to do is define a for loop to check each element of array. And this for loop will have an if statement, which will return a value if the array contains the target value. However, we will default to return false. So for, very much the same as we did last time. You know what, just for fun, let's do for and then an each loop. So for in array, we have to declare in. So for int in array, if in is equal to target, return true. Think about this logic. For each in, so we're going to loop through the array, and this array is going to successively put the value of each element into in. So the first time through, it'll put the first or the element 0 value into in, and it will run the contents of this for loop. So it'll check to see if n is equal to the target. If it is, it returns true. If it's not, then we'll go down, and then the update is to put the next value, the next element, into n, and then do the contents again. And it'll do this for each of the elements in the array called ARR. And if we find one that is equal to our target, we return true. Else, we return false. Now, this isn't an if-else. So when I say else, I'm not actually saying that this is an if-else. If this for loop runs to completion and doesn't find the value, if we don't have a return false, then there's a path that returns no value, and this won't compile. See, missing return statement. It's saying one of the paths available to this program is going to not return anything. So we have to add a return false. Now let's test this out. In our main method, let's declare an array. So integer array called array. And then we will give it the values 1, 2, 3, 4, 78. Then we will print this array contains the value and now let's define our value. We're going to call it our target, so int target equals 5. This array contains the value target, and then we will follow that with a space followed by a colon, and then we will print the results of whether or not it contains it. And we'll do that by calling contains on ARR and target. So understand what's going to happen. This is an expression. So let's read this expression like we know how. So we have operators, 3 plus signs. Plus signs have equal precedence, so we start from the left and move to the right. String plus integer is going to be a string. String plus string is going to be a string. And this method is going to return a Boolean value of either true or false. So string plus Boolean equals string. So what we're going to wind up with is this array contains the value and then the number 5 followed by a colon, and then whether or not our array contains that value. Now let's adjust the value of target to 78, and we'll print whether or not our array contains that value as well. Let's run it. This array contains the value 5, false. This array contains the value 78, true. So there we have it. We've written a method to tell whether or not our array contains a target value. A method to round all of the elements in a double array. So up till now, our arrays have all been integer type arrays. This next will be a double type array. So keep in mind, we won't have to return anything because we're going to actually be affecting the underlying object that we're passing in. So public static void, because we're not returning anything, and then round all. And the only parameter is going to be a double array, and we'll call this unrounded. So inside this array, inside this method, we need to round each element of this array that we've called unrounded. If we're going to do something to each element in an array, we can't use the for each loop. Remember, anything we do to n doesn't actually affect the array. We need to actually affect the array object. So we will do a typical for loop for int I equals 0 because we want to start at the first element of the array, and then I less than unrounded dot length. That'll let us process each element of the array, and we're going to update with I++ so that we're incrementing by 1 after each loop. Now, to round a double to the nearest whole number, we can use the math function round. We could also write our own method for it, but let's just keep it simple. And instead of importing util.arrays, we'll import util.star. So now let's see if we have math. Yeah, we do. So by importing util.star instead of util.arrays, we import all of the classes that are in the util package. Arrays is one of them, so is math. So now we can use math.round, and we're going to give as the parameter unrounded element I. But now we need to store it somewhere. This just rounds it, but it returns a double value. We need to actually store it back into our array location. So let's store it into unrounded element I. So each element I in the array unrounded will be rounded and then stored back into that element. So let's check and see if this works. So let's create our array, double, and then we'll just call it array. Then we'll say 2.1, 3.5, 3.14159.26535, and 90.991. That's good enough. So we will do a system.out.println to print this out. We'll start by telling what it is. And we will add it to arrays.toString and then ARR. Remember, we have to use the arrays class and the toString method to convert this array to a string representation to be able to show all the contents. You can't do ARR.toString. That will just convert the address stored in ARR to a string. So here we're going to print out the contents of our array. Now let's use our new round all. We forgot to document it. Rounds each element of array. Let's use our round all. And we'll print it back out. There we go. So it's parsing, building. There we go. Here's our original. 2.1, 3.5, pi, and then some odd number I've typed in. And then this is the rounded version of the double array. 2.0, 4.0, 3.0, 91.0. So notice we created an array, which means these numbers are stored as data in some array object in memory, and the location of that array object is stored in the variable ARR. Then we use the arrays.toString method to convert the contents to a string so that we could display it. Then we passed the location of that object to our method roundAll. So this gives roundAll the address of where to go and look at this array object, which contains these values. And it went through and changed the elements that are stored in that object and replaced them with rounded versions of what we originally typed in. Then we printed out the new contents of this array, and we see the changes which were made inside this method roundAll. And the reason that the changes inside roundAll affect ARR even when we return to our main method is because roundAll went to the address stored in ARR, changed the object, and then the program pointer jumped back out to here. So then when our arrays.toString method looks at the object stored in the location ARR, it still saw the changes that roundAll did to that object. It's the same object and it has the same location in memory, so whatever we did to that location in memory inside this method has been done. So when we come back out to the caller, we can see those changes. But bear in mind that the address was copied from ARR into unrounded. These are two different variables. ARR is a different variable than unrounded. But the variable only contains the address. What's important is the object that the address points to. And that's what we changed inside the method. And that's what we created right here. We created the object, we changed the object inside the method, then when we showed the object by printing it to the console the second time, we still see those changes. So two variables, both containing the same address, but one object. So for the next example, we're going to be actually returning an integer array. So yes, we've looked at situations where we pass an array into a method and then change the object, and we don't actually have to return an array because the caller can simply look at the same object. But there are times where we want to return an array, and an example of this would be the method count digits. So in this method, we're passing some integer. So in this case, 229231007, that's an integer value. So we're passing in some integer, and then we are counting the appearance of each of these digits. So there are two occurrences of the digit 0. There's one occurrence of the digit 1. There's 3 occurrences of the digit 2, right? 1, 2, 3. Then there's 1 occurrence of the digit 3, 0, 4, 0 occurrences of the digit 5, 0 occurrences of the digit 6, 1 occurrence of the digit 7, 0 occurrences of the digit 8, and 1 occurrence of the digit 9. So what we've done here is we've returned an integer array with an element for every digit. So the possible digits obviously are 0 through 9. And so in elements 0 through 9, we have the number of times that the digit 0 occurred, the digit 1 occurred, and so forth. So that's the idea for this method. We pass in some integer, we count the number of occurrences of each digit 0 through 9, and return an array of the number of occurrences. Now let's program it. So in this example method, we want to count the occurrences of each digit 0 through 9 and return an array that represents the number of occurrences for each digit. So first of all, let's declare our method header. So public, static, then return type. It's going to be an integer array return type. So int, open close bracket, and we're going to call this count digits. And the only parameter that we're going to pass to it is the integer which we want to count the digits in. And we can just call it n. So now we need to count the occurrences of each digit 0 through 9 and return an array with the number of occurrences. So let's declare our array that we want to return. So the type of the array will be int, and this is, let's see, what do we want to call this? This is our digit count. And then we'll stick ARR on the end of it so we know it's an array. So mostly when we've been declaring arrays in these examples, we have been using this syntax, right, where we use curly braces and then explicitly declare the starting contents of the array. But we want this array to start with all zeros because our initial state for this array is going to assume that the count for each digit is 0. Well, when we declare a new array object and say we want 10 elements, so this is another way of declaring an array with 10 elements. So we say new array object of integer type with 10 elements, this will automatically initialize each of those elements to 0. So we don't have to do it explicitly. So we have something to hold the count for each of our 10 digits, 0 through 9. Now we need to have a way to process our integer and tally up the number of digits, or tally up the number of occurrences of each digit. So what we're going to do is we're going to use a while loop. And we're going to modify int as we go. So we're going to say while n is greater than 0, then we're going to declare an integer called last digit. We're going to set it equal to n mod 10. Then we are going to update n by doing n divided by equals 10. So this will divide n by 10 and store the result back into n. So that will remove one digit. Then we are going to increment digit counter array of last digit. So this statement is going to get the last digit in n. So if we have the number 91, 91 mod by 10 results in the value 1. So we would store 1 in last digit. Then we get rid of that 1. So 91 integer division by 10 equals 9. So we get rid of the 1. And now we need to increment the count for the digit 1. So last digit holds the value 1, and we can use the value 1 to address this array. So we say go to element 1 and increment that element. This will go until n is equal to 0. So in the case of 91, in the first time through this loop, we say 91 mod 10, so last digit equals 1. Then we say n divide equals 10, which means n is now 9. Then we increment element 1 because last digit has the value 1. Then we start over. Is n greater than 0? Well, n has the value 9, so yes. 9 mod 10 is going to take on the value 9, so last digit is now 9. 9 divided by equals 10. 9 divided by 10 for integer division is 0, right? Because it would be 0.9, but when we're doing integer division, we chop off any of the remainder. So this results in 0. We increment element 9. We're at the end of the loop. We jump back to test. Is 0 greater than 0? No. At that point, we need to return the results of our counting of digits. So we will return digit counter array. Then in our main, where we're going to test this, we're going to test it with a number that we had in our slide. So let's declare a variable called int result, and we'll set it equal to count digits of 229231007. Oh, that's right. So notice we're returning an integer array, but I attempted to store that integer array into an integer type variable. And it says that's not okay. Required type int for, that's because we declared an integer type variable, but this expression is going to result in an integer array result. So we have to declare this to be an integer array type variable. Then we will print out the results. So system.out.println. Then we're going to say count of digits. And then we are going to convert our array to a string. And the array is called result. And then we'll do it again. We'll say count of digits 4 and space and then here we'll put our number 229231007. And let's do one more example of it. So we don't need to declare it again. We just need to store it in that result variable. So this time we're just going to give it the number 454. 454. Now let's run our method. So we are building, parsing, finished. So we said that for the number 229231007, so 229,231,007, we would have 2 occurrences of the number 0. That's correct. 1 occurrence of the number 1. Yes. 3 occurrences of the number 2. 1, 2, 3. Yes. So this is exactly right. You can go through and finish counting if you want. Notice then when we passed it the number 454, this is for digit 0, this is for digit 1, this is for digit 2, digit 3, here's digit 4. So we had 2 4s and 1 5. Our method works perfectly. There's one other point to be made about returning arrays from a method. So notice here, we call this method count digits and it returns an array to our main method. But remember, what's actually happening is that inside count digits, we are creating an array object and then returning the reference to that array object and storing it in this result variable. So if you remember in the previous example, we were able to print the location of that array in memory. So for fun, let's print the location of this array in memory. This array is located at, and then let's say result. So this will print the location of result, of the result array, because remember, what is stored inside this variable result is actually the location of the array. Then, when we call count digits again and return another array object and store it in result, or to be more accurate, when we call count digits method and it returns the reference to another array object which is stored in result, we're going to see that it has changed. So the new location where the array is stored is going to change. And the reason is because we call this method and it builds a new object and returns the location of that object and we store it in result. When we call this method again, it builds yet another new array object and we store this new object's location into the variable result. So it's going to change the location. So when we first call it with this long number, we see the result that we talked about in the previous slide, and we see where that array was stored. Some weird encoding starting with a bracket, but 72E, A, and so forth. So that's where this array object is stored in memory. Then we gave it the number 454, and we counted the digits, and we returned this array representing the digit counts. This array object is stored at 33C75, so forth. So you can see the location where this array is stored is different than the location where this array is stored. But notice, in both cases, we printed what was in result. What's happened here is we called this count digits method, which made a new array object in memory and gave us the location into result, and that's this location. Then when we called count digits again, it built yet a further new array object. That's what this new does. It literally creates a new integer array object in memory, and so it can't exist in the same place as the last array object it existed. So it creates a new array object in a new location, and then that location is stored in this variable called result. So when we print out that location, we can see that it has changed. It's no longer the same location because we're no longer dealing with the same object. We built a new one, and now we're dealing with this new object. For our next example, we're going to write a method called stutter. Stutter will accept an array as a parameter and will return another array. So these are going to be arrays of type integer, and what stutter is going to do is repeat each value in the array. So given the input 1407, stutter will produce an array as output with the values 1, 1, because we stuttered the 1, 4, 4, 0, 0, 7, 7. So we've caused each element of this array to be repeated. There's a couple of reasons that we're going to return an array rather than try to modify the existing array. First of all, notice the length of our array that we're returning does not equal the length of the array that we pass in. Therefore, we wouldn't simply be able to modify the elements of this array to be able to achieve this functionality. So if we need to change the length of this passed in array, it's probably better to return an array rather than try to make those changes in the array which was passed in. Second of all, we might want to keep both the original and the stuttered array to be able to compare them. So if you find yourself in a situation where you need to change the length of an array, or if you find yourself in a situation where you want to have both the array that you passed in as well as the modified version, then it's probably best to return a new array and leave the original object unchanged. These are some of the reasons why you may want to return an array as a value rather than modifying the object which was passed in. So now let's actually write the code to accomplish the functionality for this example. So now let's write the code for our stutter method. So this method is going to create and return a new array with each value in the parameter duplicated. Then we'll do our heading, public static. We're going to return an integer array type. We're going to call it stutter, this method. And we're going to pass in a parameter, which is an array of integer type, and we'll call it nums. Now, the first thing we need to do is build the array which will house our stuttered version of nums. So we've said that we want to duplicate each element in nums. So that means that the resulting array needs to have twice the length. So if we had an array which had the contents 1, 2, 3, 4, we would want an array that resulted with the contents 1, 1, 2, 2, 3, 3, 4, 4. So in the original array we have 4 elements. In the second array we have 8. And that's going to be the case in every instance. We're always going to want to have twice the number of elements. So let's create an integer array called stuttered, and we'll assign it a new integer array object with 2 times nums.length. And we're assuming here that the length of nums is greater than 0, because if it's 0, then we're creating an array with 0 elements. We're going to assume that the length of nums is greater than 0. So now we have our container. Now we need to populate the container. So let's use a for loop. And let's look at each element in our nums array. So to do that, the first thing we need is our counter variable. So int I equals, and we start at 0 because arrays start at the 0 index. We're going to go until I is no longer less than nums.length. So this will allow us to process every element in the array. And then we're going to update our counter variable I. So obviously we're going to be assigning something into nums. Or sorry, that is incorrect. We're going to be assigning something into our stuttered array from the nums array. So we're going to assign it into stuttered element 2 times I. And we'll talk through this in 1 second. So we're going to assign into element 2 times I what is in nums element I. And we're going to also assign that into element 2 times I plus 1. So think about this. We want to put the value in element 0 in element 0 and element 1. So 2 times 0 is 0. 2 times 0 plus 1 is 1. So now we have stuttered whatever was in element 0. Now we go to element 1. I takes on the value 1. So we want to stutter what is in element 1 of nums into 2 times 1, so element 2 of stuttered, and 2 times 1 plus 1, element 3 of stuttered. So by multiplying I times 2, we are spacing out and putting the contents of nums in every other element of stuttered. We duplicate whatever we put into that element into the following element. So 2 times I plus 1. So this will populate 0, then 1, then on the next iteration through 2, then 3. On the next iteration through, I now has the value 2, and we just populated element 3. So 2 times 2 is element 4. 2 times 2 plus 1 is element 5. Then I will take on the value 3, and we'll pick up at 6. So this will allow us to populate the array as we have discussed, so that element 0 of nums goes into both element 0 and 1 of stuttered. Then we need to return stuttered. So let's test it. Let's build a variable to hold it. Result equals stutter, and we will pass the array 1, 2, 3, 4. Nope, doesn't work. Can't do that. You can't declare an array literal like that. To stutter. So I was showing you, you cannot use an array literal like this as a parameter. You can only use this as a declaration of a new array to be assigned to an array variable. So this will stutter this toStutter array and store in result. Then we need to print the results. The original we have to use arrays.toString and toStutter followed by system.out.println the stuttered. And then we'll do the same thing again, arrays.toString, and then in this case we'll use the result. So this will print the original, followed by the stuttered version. So 1, 2, 3, 4. 1, 1, 2, 2, 3, 3, 4, 4. If we change this to be 0, 3, 6, 6, 7, we get 0, 0, 3, 3, 6, 6, 6, 6, 7, 7. So this final method is called merge. We're going to accept as parameters 2 arrays, and then we will return an array with the first array occurring followed by the second array. So all of the elements in the first array followed by all the elements in the second array. So this method will merge 2 arrays ARR1 plus ARR2 into ARR3, where ARR1 and then ARR2 follow in that order. So we'll do the normal recitation public static, and then we are going to have a return type of integer array. It's going to be called merge. We give 2 integer array types, one ARR1, the second ARR2. So the first thing we need to do is create the container ARR3 which will house our merged array. How big does ARR3 need to be? We know we need to use the new keyword to create a new array. And here's where we have to tell it how big we want it to be. It needs to house all the contents of array 1 and array 2. So we can do array1.length plus array2.length. Remember, this just has to be an integer expression. It has to evaluate to an integer value. Well, length 1 plus length 2 is going to evaluate to an integer value because length 1 and length 2 are both integers. Now we need to process array 1 and array 2, copying each element from array 1 into array 3, and then copying each element of array 2 into array 3. So let's use a for loop to process the first array. For int I equals 0. Hopefully you know why we do that at this point. And hopefully you know why we are going to use the length field as the test. I++. And this is the easy one. We'll put them in location I or element I of array 3 if they are in element I of array 1. That's the easy version. The harder is going to be how to process array 2, because it can't start at element I. It can't start at element 0 because element 0 through length of array 1 is already taken. So we'll have to start our I at 0, but then we'll have to be careful about how we introduce new values. So we're going to process all of array 2. So this heading for the for loop is going to be the same as we've seen previously. But now, where are we going to put it in array 3? If I put it here in I, when I has the value 0, it's going to wipe out the value of element 0, which we just populated from array 1. So we can't do that. So what if we say location I plus array1.length? So when we are writing to I plus array1.length and I has the value 0, then we're starting at the length of array 1. So let's make this concrete. Let's say array 1 had a length of 10. So this for loop processed this array from I equals 0 to I equals 9. When we finished I equals 9 and updated to I equals 10, we compared 10 to see if it was less than the length. The length was 10, so we did not execute this loop again. So if we begin to process array 2 and write the contents of array 2 starting at location 10, then we know that we are not writing over where we left off in the previous array. We know that we're writing to a position that we haven't already written to. So that was a specific situation where the length was 10, but we can make it general just by using array1.length. And now we assign array 2, starting in location I, to this location in array 3. So here, element 0 goes to element 0 in array 3. So element 0 in array 1 goes to element 0 in array 3. But when we process array 2, we want to pick up where we left off at array 1. So we start populating array 3 at whatever the value of I is plus array1.length. And we just started I over at 0. This variable I only exists inside this for loop because we initialized it and declared it inside this for loop. So when we exit this curly brace, I dies and goes away. So we have to redeclare it inside this for loop, and we gave it a value of 0. So when this loop begins, array1.length is exactly where we left off from writing in this previous array. So as I said, if array1 has the length 10, the last location we've written to then in array 3 is location 9. So when we come to our second for loop and we begin writing at 0 plus 10, we know that that is the very next location after the end of array 1. So this will do exactly what we want. Then we can return array 3. So let's test it. In our main, let's create an array of integer type called array1. Just keep it simple. And we'll go 1, 2, 3, 4. And then we'll call this one array2 equals, 5, 6, 7, 8, 9. Now we're going to capture the return in array 3 equals merge of AR1, AR2. Then we're going to print out something to tell what we're doing. So this line's getting a little bit long, but we're just okay right there. And then finally we'll print out system.out.println merged array. And run. Contents of array 1, 1, 2, 3, 4. Contents of array 2, 5, 6, 7, 8. Contents of the merged array, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, one thing I'll point out here, we didn't actually have to create another array type variable. We could have simply done that right there. So here we are calling our method, passing the parameters, and then immediately passing whatever is returned from merge to the toString method of arrays. And this will work just fine. So now we're going to shift gears and we're going to talk about a common problem in CS. Searching. When we say a common problem, what we mean is it's a common goal for an algorithm to solve. So we've looked at searching already. We looked at searching when we were looking for something in a file. And the way we approached it was a sequential search method. Sequential search usually looks like this. Look for the item in the list. If you found the item you want, stop. If you haven't, look for the item in the list. If you found the item you want, stop. If not, repeat 1 through 3 until you either find the item or you run out of items to look through. So let's look at some code for a sequential search method that'll accept an array of integers and the value that we wish to search for. This method should return the location or a -1 if it's not found. Now this is going to look remarkably similar to our method we already programmed called contains. So in contains, we were looking to see if a certain value existed in an array, and if it did, we returned true, otherwise we returned false. This is a very similar algorithm, however we want to return the location instead of whether or not it exists. So in this algorithm, in this method, we are returning an integer because we want to return the location in an array. And we have our parameters, an integer array, so this is incorrect. Our bracket should be over here. So we have an integer array that is incorrectly defined, and we have an integer called target. So we're looking for target inside of this array. So just as we've done in our examples, we start our counter variable at 0, we go till array.length because we want to look in every element of the array for target, and we increase our counter by 1 at the end of each loop. Then we are going to check to see if element I of the array is equal to our target. Now in our contains method, we returned the value true if we found an element equal to target. However, in this case, we're going to return I, because that will be the index of this particular element. If, after searching through this array, we have not found it, so after this for loop completes, and we haven't returned a value, we'll return -1, which means the value that you're looking for, the target that you passed, does not exist in ARR, or array. So this is a sequential search. It's a simple algorithm. It's how you might look for a file inside of a mixed up file cabinet. You pull out a file, you see if it's the one you're looking for. If not, you lay it aside, and you continue that until you find the file that you're looking for. It's sequential and it's exhaustive because you have to search through every single element, every single file in the cabinet to be able to find the file that you're looking for, or to be able to say with certainty that the file for which you are looking does not exist in the filing cabinet. Sequential search will definitely find the answer. We'll definitely be able to find out where the item is located if it exists. But in computer science, we always ask the question, can we do better? Like we said, this is a bit of an exhaustive method. To be able to prove that it doesn't exist in our filing cabinet, as an example, then we have to look through every single file. What if there were 10 million files? That could take a lot of time, even for a computer. So is there a better way to search for things? Well, let's use how we look for contacts in our phone as inspiration. When you look for a contact, and let's say you're looking for your friend Zelda, do you start in the very first location and begin to search from A and then search through all of B and C and D? No, right? You have your contacts in a sorted order. They go from A to Z. Imagine if all your contacts were in random order in your phone and your phone didn't sort them for you. Imagine how difficult it would be to go through and find the person you're looking for if you have some 500 contacts in your phone. But if we're dealing with something that has a sorted order, so in our phone, when we type in someone's name and create a contact for them, it puts them in alphabetical order. If we are dealing with something that is sorted, we can do a little better than sequential search. Actually, we can do a whole lot better than sequential search. So let's consider this algorithm for when we are dealing with an array that is sorted and we want to search for a value. Let's start by checking the middle. We don't have waypoints like we do when we're dealing with our phone and we're looking for a certain letter. Our phone puts waypoints for us to easily say, oh, it starts with the letter D, But in an array object, we don't have those waypoints. So this is a generic algorithm that doesn't assume any of those waypoints. So start by checking the middle item in the array. Then, if the middle is not the target, we've learned something, right? Let's say that in an array of 100 elements, we're looking for the number 25. And we look in the middle first. Let's say the middle then, let's say each element increases by 1, so it contains all the numbers 1 to 100. And we look in the middle, we're going to find the number 50. Well, when we compare the number 25 to 50, we realize that the number we're looking for is less than the middle. So we know that we should go to the left of the middle. If we were looking for the number 75 and we went to the middle and we found the number 50, we would know that we should go to the right of the middle. So immediately we were able to eliminate half the array because we knew that it didn't contain our target. When we're looking for the number 25 and the middle is 50, we know that we can eliminate the whole right half of the array. This generic idea is called binary search. So here's an example of binary search. We're looking for the number 57, and this is our array of values. Notice they're in sorted order, so they go from lowest to highest, and there's 10 elements in this array. So if we were to want to find the number 57, first of all, 57 doesn't exist in this array. To be able to prove that 57 doesn't exist in the array, using sequential search, we would have to check element 0. Is this what we're looking for? No. Element 1. Is this what we're looking for? No. How about 2? No. 3? No. 4, 5, 6, 7, 8, 9. Hey, it's not here. We had to check every single element in the array. But notice how much better we can do by using binary search. So the first location we're going to look at is the very middle. So the middle in this case is min plus max divided by 2. So element 0 plus element 9 is 9 divided by 2. 4.41. So that's not 4.41, that's what it looks like, but it's in position 4, right? 9 divided by 2 when we're doing integer division is 4. It's 4.5, but we chop off the 0.5 because in integer division we don't have remainders. And we don't round in integer division either. We just chop off whatever the remainder is. So position 4, so 0, 1, 2, 3, 4 is 41. Well, we're looking for 57, and 57 is greater than 41. And we know that this array is in sorted order. So we know that everything to the left of 41, everything to the left of position 4, must be less than 41. So we know that we can't find 57 to the left of 41. So that leaves only these options. So now, our second guess is going to be the minimum possible location plus the maximum possible location divided by 2. So we know it's not in position 4, so that's not our minimum anymore. Our minimum would be position 5. So 5, and our maximum is still 9. So 5 plus 9 divided by 2 is 7. So 14 divided by 2 is 7. So position 7 contains the value 71. Well, 71 is too high, right? 57 is what we're looking for. So if all the values to the right of 71 are in sorted order, that means they must all be greater than 71. We definitely won't find 57 over there. So we've eliminated all those values. So now, the only possible location is here. Notice, every time we execute this operation, we divide the possible space that we need to search by 2. Originally, there were 10 locations. We looked in one place, and we're immediately able to eliminate 5. So we eliminated half of the locations. We checked again. There were 5. We eliminated 3. So we eliminated half the locations. Now, we need to again take the minimum possible location and the maximum possible location, add them and divide by 2. 5 plus 6 is 11, divided by 2 is 5.5. In integer division, we chop off the remainder, so position 5. So we check position 5, it's 55. It's too low. So that means the only remaining possible location is position 6. And it's too low. So therefore, we know that the item is not in the list. So, to do sequential search, we would have had to check a total of 10 locations. But by doing binary search, we were only required to check 4 locations. That may not seem like a dramatic improvement, but imagine if we scaled this up to millions of locations in this first array and said that we could speed it up by 60%. This was a 60% speed up. So binary search is significantly better than sequential search, but binary search requires that our array be in sorted order. Let's look at another example of a binary search for 17 in this array. We're looking for the number 17 in this array. So the very first thing we need to do is choose our first location to search. We always choose the minimum possible location plus the maximum possible location divided by 2. So in this case, that would be 0 plus 10 divided by 2, which will be 0 plus 10 divided by 2 is 5. So we check the middle of the possible range. We're always checking the center of the remaining possible range. So right now we've not eliminated any parts of this array. So all of this array is a possible location for the number 17 as far as our algorithm is concerned. So we search the middle of our possible range, and we find that the number we're looking for, 17, is less than the element in location 5, which is the middle of our possible range. So since it's less than the element, we know that we have to search over here. Everything over here is going to be too big. 17 was already less than the middle of the possible range, So therefore, if everything to the right of this element is in order, which we assume that it is, if we're using binary search, we've assumed that this array is in sorted order from lowest to highest. So we know that we can't find 17 to the right of the element we just checked. So our new range is going to be from the very first element all the way up to middle minus 1, which is position 4, element 4. We always check the middle of our possible range, so we do the lowest possible position plus the highest possible position divided by 2 is our middle, and we check the middle of our possible range. So we check the second element, and we find the number we're looking for. So 17 equals the element in the middle of our remaining possible range.